Well, good morning, everyone. Thanks for coming out early on the day after the bash. So they scheduled us during the workshop slot, but to be clear, this isn't a workshop. So if you were looking forward to doing some like lab work or something, there's still opportunity to bail and go next door. Also, I think Ben next door, I think he's anxious about the Wi-Fi over there. So maybe turn off your Wi-Fi in here to give our friends over there some extra bandwidth. My name's Joe. I work at Facebook on the client platform engineering team. And today's talk is kind of an unofficial sequel to what we talked about last year here in London, when I talked about how we use our Chef API model to kind of distribute out the workload to our own customers and to the end users to allow them to control some of the configurations on their own systems. And to quickly recap how we utilize or why we utilize this API model, there's a few reasons. One is that it fosters kind of a sense of ownership on the part of the users. They can feel like they have a little bit more agency in how their systems are set up. It encourages buy-in from a user base who are mostly developers, and they're used to working with APIs in their own day job. So providing them with that model makes it a little bit easier to get some buy-in from them. Third, we as CPE may not even know what the appropriate setting or what version of an app that a particular department might need. Or finally, it may not even be up to us to decide. It might be up to some security group, or there may be a vulnerability detection team that wants to make a change to fix a problem that they see on their end. And the reason that Chef makes this really easy to do is that everything is in code, and that makes it easy to audit, easy for us to share ideas. It provides kind of a standard platform and model for configuration management that users can use across the different cookbooks. Because it's in code, all changes are code reviewed. So if you want to make a change that, say, applies to your own system, you can't just go in there and secretly make that change and submit it. It does have to go through review. So somebody, one of your peers, will have to review that for you. And if it's a particularly gnarly security thing, then it might go to a gnarly security team for review as well. And then they can come back to you and ask for further justification. And because Chef runs cookbooks in a predictable order, we can tailor the Chef run to kind of configure systems from a broad scope down to a more narrow scope as the Chef run moves along, all the way down to like even a node or just a one system or a one user change. And the reason we can do this deterministically is because Chef during a run actually does a few loops through all of the cookbooks. At the very base level, it runs through and collects a bunch of attributes about the system and about the changes that you want to make. And what we do is during the attribute compile time stage, we typically just mark everything as empty or null or false. That way, if that's all that is in the Chef run, nothing will happen. It won't make any changes. And then further along in the Chef run is where we want to start defining that state. On the second loop, it runs through and looks at all the recipes. And this is the part where we start collecting data about what the changes that we want to make on the system. And because we know the order in which Chef runs, we can have a broad configuration at the top. And as the Chef run goes along, you can overwrite those configurations all the way down to your own system. And finally, when Chef converges, what they call the Chef runtime, the resources will write these changes to disk. And resources can be as simple as just a Ruby script or using the Chef declarative language. And it can apply to the system based on a wide variety of instructions that it received during the chef run. And since we know the order, again, in which chef runs, the last known value of any of those node attributes is the current value, and that's what will be written to disk. So a quick example of how you can use this is with the Spotlight preferences. Say you want to add a folder to exclude in Spotlight. Typically, you would just go into System Preferences and you can click on the plus button, add your folder there. In Chef, we can declare a CPE Spotlight node attribute. And again, we just want it to be empty because we don't want it to actually take effect on any machines to start with. So if we leave it empty, Chef will come along and say, oh, there's nothing to do, and move along from there. But if we want to include some directories into that list, we can pass it that value into an array inside that CPE Spotlight exclusions node customization or node attribute. So in this example, you'd be making this change most likely in a user or node customization that you would want to only apply to yourself. And then you can define your own configuration state, submit this change, have it reviewed and accepted, and then when Chef runs, when it gets to the part where it compiles and writes the configuration profiles to disk, it'll include your change in that configuration. In this example, I've added a source directory to my own Spotlight exclusions list, and because I only added this in my own node customization, which is tied to the serial number of my machine, that change only takes effect on my machine and doesn't affect anybody else in the fleet. So that's it for the follow-up from last year. I kind of want to back up a little bit and talk about node attributes in Chef and how they're initiated, how they're changed and applied and updated, and how you can call them from within Chef recipes during a Chef run. So everything in Chef is part of a node object. It's just basically a giant hash. I think it's a little bit more complicated than that, but you can think of it as just a big dictionary of keys and values. An attribute is a specific detail about a node, and attributes are used by the Chef client itself to understand things like the current state of the node. Are you on corp, are you off corp, are you on VPN? It also knows the state of your system at the end of the last Chef run because it writes those values to disk, it ingests those, so it can make some determinations about what's changed since the last time that Chef ran. And then finally, at the end of the current run, it will write everything back down to disk, so the next time it comes around to run, it'll, again, know the current state of your system. And during the Chef client run, Chef builds this node attribute using data about the system that it collects through a variety of means. One of them is the Chef Ohio plugin system, which is kind of a series of scripts that you can put into a plugin that will always run at the beginning of a Chef run. And it can gather information about your system, kind of similar to Factor on Puppet, if you've used that. And then this data is stored in memory during the Chef run where it can be used and then written out to disk at the end of the Chef run so that it can be referenced again later. And then as Chef converges and finalizes, it applies all the changes to disk. It looks at anything it needs to do based on the current state versus what it thought the state should be. It makes those changes and writes to disk and then lays down some files to kind of log everything that it has done. So an attribute can be a specific detail about a node, such as group membership in or a department membership of a user group, or maybe the system OS version of the operating system. But it could also be a more fluid or dynamic value that you customize and apply to disk. For instance, you could set your own login window banner to be whatever you want. And then when Chef comes along and makes those changes, it would only apply to a certain subset of systems. So node functions are something that we have in our open source CPU util cookbook, and it's a library of a bunch of Ruby modules that can further collect data about the system. And it's meant to be more of kind of an on-demand usage. So whereas the OHI plugins will always run at the beginning of Chef, that can be a little heavy. You may not want all of these data collection routines to be running during every Chef run, because if it runs every 30 minutes, it just adds more tax to the system. So the way that node functions are initiated is they're called from a CPU util library. And so in a cookbook, you can make deterministic choices about things by calling a node function, such as give me the current OS version, give me the current username, the IP address, that sort of thing. You can think of the node attributes as facts about the system, and node functions as dynamically derived facts that you're adding to that list of information. So it can be stuff like serial number, amount of memory, applications that are installed, versions, the model identifier, anything that you would want to have at your disposal to make a decision about what you want to change. They can be dynamically derived. Again, Chef will know if you're on corp, off corp, on VPN, and then can make changes based on that knowledge. So an example of a node function that we have is determining if a machine is virtual or not. And we could use an OHI for this, but we may not want this to run on every system. We might want it to only run, say, during Bootstrap, if we want to make some different choices about what gets laid down on disk during Bootstrap, whether it's a VM or not. So in our open source CPU utils, we have some modules for looking at I think it's looking in the BIOS, and determining whether a system is virtual, and further what type of virtual machine it is. So if it's VMware or VirtualBox, or Parallels or anything else, any other hypervisor that you might have. When that is inspected, it shows the other function that's calling that actually derives that system. It's pulling it from the boot ROM version. In this case, looking just for those characters VMW to determine that it's a VMware system. So you could do something like this where you don't want the screensaver to kick off in VMware unless you like having a space heater in your room. So you can have Chef determine if it's a VMware system and set the screensaver to 0 for all of those systems on your box. Node attributes can also allow you to gate cookbooks in a way, for us, because it's cross-platform. A lot of our cookbooks are gated to either just Mac OS or just Mac and Linux and not Windows, or maybe all three. Maybe only on Mac OS, and if the system's not running at the login window. So we can put these early returns in Chef to have it just kind of bail and not worry about the cookbook if it doesn't meet these general requirements. In this example, we only want the file vault resource to run if the user is logged in. We want it to bail if it's sitting at the login window. Another tool that we have at our disposal is OSQuery, of course, at Facebook. And in that same open source CPU util library, inside the CPU util cookbook, we've built in some functions that call directly to OSQuery to be able to determine information about the systems. Any query, any OSQuery query that you can query in the interactive mode can also be passed directly to this node function in Chef. So if you just want, I think this is just pulling the seconds from the time counter. So anything that you could do in OSQuery I, that SQL query, you just pass directly in. And here's an example of how you can pull the username from the Nomad preferences. And this may be useful if you're in an environment that's using Nomad with local accounts, and the local account name may not match the Active Directory name. but you want to make some change based on the value of the currently logged in user's AD username. This could be a quick way to determine what that username is. And then Chef will say, okay, cool, even though this person's logged in as Foo, their username is in fact Chilcote. And in this example, I hard-coded the name there, but you would pass that in through another node function. And then you just pass that to the OS query library, and it accepts that SQL query and spits out the answer as a hash that you can then do with what you will. In this case, I could see that my username is in fact Chilcote. Another example here is a query to figure out what version of an app is installed. You may have some dev tools that you only want to install for users who have a particular version of Xcode. You can make that determination here via OS query and not have to worry about shelling out to some other bash script to be able to pull that information back in. So anything that's available in OS query is available to Chef, so you can pull in preference domains, hardware stuff. You can get information about what launch daemons are installed, kernel extensions, and whatnot. And then this could be used to further gate your changes based on the current state of the machine. Gating is kind of what I've been talking about with these early returns. You can easily gate configuration changes based on hardware type or location, username, group membership. But you could also use externally derived knowledge about the user that's logged in. So you could query AD or LDAP and figure out something. You could query some other API that tells you some information about the location that you're in that maybe might have more strict guidelines about what can run and what can't run. You may have particular offices where you don't want, where you have more data loss protection criteria than other offices, and you can make those determinations based on IP address, that sort of thing. One of the node functions that we have in our CPU util is the greater than or OS less than. And there are others like OS at least or earlier or something like that. But we have a lot of ways to just return a Boolean, a true or false statement about the system, and then we can make choices based on that value. So an example of where we use this internally right now is with deprecation notifier. We can say any machine that's between 1013 and 1013.99, so you can safely assume that they're on High Sierra. Apple is still shipping High Sierra releases, right? And when that Mac is on Mojave, Chef will know that it's on Mojave, and so it'll just skip this whole thing. Otherwise, if it's on High Sierra, they'll get that lovely deprecation notifier that your users have grown to enjoy. We can further gate things based on sharding our systems. In our case, we split the fleet up in chunks of 1%, 1 to 100. And this allows us to do small localized tests and also slow roll some changes out to the fleet. Certain large package installs, it may be a good idea to not hit 100% of your fleet when you have 50,000 machines. You can very easily kill your network or bring down an entire region of the United States, which we've certainly never done. And this allows us to kind of slow roll some of these changes out, and also to kind of see the impact of the change that you're making. If you're only hitting 3% of the fleet with a change and you discover, oh, we made a mistake, it's easier to roll that back when you're not trying to roll back 100%. For Macs and Linux clients, we use the serial number to determine this shard. On Windows, I think it's using the system UUID, because Microsoft. In any case, the node attribute just takes that serial number, performs some math, and then gives you a value of 1 to 100. so that it just chunks up your system into a shard. So then you can have these call sites in your Chef code to determine whether a system is within a shard. So if you only want to affect 30% of the population, you can ask it, are you in the shard 30? It'll return a yes or a no. And with that value, you can either decide to do something or skip it and move along. And then later on, when you want to expand that sharding out, you can change that value up to 31 or above, and then it'll slowly start affecting more and more of your fleet. And we have a few functions that take this shard value and do some more interesting things with it. Sharding over a week is something that we use a lot, and it allows us to slowly roll out a change over a week and gradually hit more and more of the systems. So I think the way we do it is 1% on day 1, 10% on day 2, 25, 50, and then 100. So if you started out on a Monday, you're only going to hit 1% of the fleet. And again, you discover that, we introduced a bug that shuts down everybody's computer. We can roll that back and only have to remediate 1%. And then by the end of the week, by Friday, it will hit 100%. And we do this for things like rolling out Monkey, because we don't want our package delivery system to be interrupted too much. So we do slow roll things like that out to the fleet to make sure that we're not making any mistakes. Handlers in Chef are kind of routines that run at the end of a Chef run. You can think of them as kind of analogous to a post-install script. They're processed after Chef has completed its full run. It has all the information that Chef knows about the machine, including all the changes that you just made. Common uses are collecting exceptions or error data, or just submitting run data to a log aggregator of some sort. So again, you have a successful Chef run. You could send all of your Chef logs to your log aggregator. You can ship it to Splunk or use Sal or something to gather all of that data up off of disk. Similarly, if there's an error, you can send all of your exceptions to a report generator, build dashboards based off of that, and then that way you can easily see trends about what is and is not failing within Chef. We do send errors in the stack trace to an internal log aggregator. So in our Chef dashboards, we can easily see, there's been 100 errors in the last hour. They all return this error message. Here's a link to one of those stack traces. So we can quickly go in and look and figure out where exactly it failed. In this case, I think it just couldn't reach our repo to download the Monkey package, if I'm reading that correctly. Another handler that we make of is to ship data about our machines to a centralized dashboard. You could do this with Sal. You could do it with Splunk or any other aggregator that collects data of your machines, and then you can build dashboards based off of. When Chef completes its run, our CP info handler runs and ships this data to an endpoint. And from there, we can run reports. We have dashboards. We have alerts. And it's a quick way at a glance to see the current state of your fleet. You can, if you're pushing an OS update, you can see very quickly the percentage of the fleet that have run that update, who is left to go. So with Chef handlers, you could even save this data directly to disk in, say, a JSON format like this, and then have something else come along and process it and pick it up. Maybe even OS query could do that. Another topic I want to cover is the CP remote cookbook and resource. This is a way for us to install packages or copy down files or zip files from remote source. And it kind of allows us to, there's some things that we may not want to install via Monkey that we want to install via Chef. So we have a CP remote package resource that you can pass some information about the package, like the name, the checksum, and whatnot, and it'll reach out to a predetermined repo and grab that down and install it locally. And packages is what this example will cover. So we create a little hash here with the Nomad name and checksum, compile that into the node object. When the CP remote resource comes along, it accepts all this data. It says, okay, cool, they want to install this thing called Nomad. It has this checksum, it's at this location. I'm going to go grab it, make sure it's the correct one, and install it if the system needs it to be installed. So this way, with the Chef API model, you could have a generic setting for the version of Nomad that you want to install. Later on in the Chef run, you could have like a beta version that only gets applied to, say, your own team's systems to do some testing. In the resource, in this case, it's the CP Nomad resource. It compiles all this information into that node object. The CP remote resource does expect a few values. It expects a name, it expects a version, and a checksum. Things like package URL can be predetermined at kind of in a global setting, and you may not need that to be customized for the particular package that you're trying to install. Then when Chef converges, it'll install, it has a list of packages that you've told it you want it to install, and it'll just loop through them and download and install those. So that just covers kind of a handful of some of the clever things that we do within Chef to manage our Macs. What I want to show you now is just a real quick example of how a custom cookbook resource can come together and how it behaves as the Chef run progresses. And for that, I chose how we installed this vFuse virtual VMware testing system. It's just a bunch of scripts that get installed so the user can invoke it. It'll download and configure a VM for them, spin it up, and they can do some testing and then delete it at will. So our goal in this example is we don't want the user to have to worry about anything. We want to just install it for anybody who's joined a particular testing group or has otherwise opted in. We don't want to install it for everybody because we like to keep our configurations lean, and we don't like to install things on everybody's systems if only a few dozen are going to be using them. And we also want to configure some predetermined configuration files so that they don't have to worry about setting values in their VM, like the host name or the serial number or things like that. We want to make it as easy as possible for somebody to get started testing in macOS. And also there's a few bugs that we have to work around that we do some fun things in Chef. So the attributes file and the recipe and resource is all we need for this. And these are kind of the basic ingredients of a Chef run. There are other things that can fall under this directory structure, like libraries and templates and files, but we're not worried about that with this. The attributes file is where we set the default values, usually setting them to, again, be empty or null or false, so that by default they do nothing. The recipes file in a custom resource like this is essentially just a way to declare the resource and call it so that it functions. And then the resource file is where all the code lives and applies the changes that you want to make to disk down. In the attributes file, this is what it would look like by default. Again, everything is pretty much generic or empty. And because of this, on the vast majority of the systems, nothing will happen because the resource will come along and say, oh, install is set to false, so there's nothing to do here. I'll just move along. But it is important to declare these values in your attributes file. You don't want to just leave it blank because you could get to a situation where later on in Chef, somebody is saying, hey, is install set to true or false? They receive a nil, and then you end up with a type error and unhappy times trying to figure out where to go back to fix that. So if one of the values doesn't exist, Chef will just ignore that value and move along and try to figure out how to work around it. Now that we've initialized our base settings, we can start to populate them. Typically what we do is in some kind of generic broad cookbook, base settings cookbook, we can start configuring these attributes with positive values. And since we want the same version to be installed across the entire fleet, we can put that into this broad cookbook that gets applied to everybody. And because we're not setting install to true, it won't really matter, because when the resource comes along, it'll be told not to install anything anyway. And like I said earlier, the package resource itself, the remote package, does expect a few things like the value of the name and the version, the receipt, and the checksum. It looks for whether the product is already installed and will skip it, and does a few other checks like that. Further along in this base settings recipe, we can continue to define the node attributes. We can set a template directory where we want to lay down all the little JSON templates that the scripts can use. We can configure the QEMU path. Again, because of a nagging bug in VMware Fusion, we use the open source or the free QEMU product to actually do the converting of the DMG into a VMDK. We can set a default log path, which lays down some basic information about the template that's being used in the VM that's being created, which then gets slurped up by our log aggregator, so we can pull reports on who is using what. And still in the base settings, we can define the URL that we want it to grab that DMG from. And we can define as many of these as we want and just kind of shove them all into a hash, and it'll come along and just create as many of these templates as you want. The template expects a few things like the output name. Source DMG is that URL that we defined earlier. We're passing it a checksum so it can make sure that the DMG it's downloading is the one it expects. And if we want caching or snapshotting to be set to true, so for testing in VMware, it's pretty convenient to cache that DMG locally so they can recreate it, and also to configure a basic snapshot so that they can revert back during their testing. And then finally, when we want them to run the product against the template, we can log that and get that into our log aggregation. So if we look again at the attributes file, everything that we had set as false or nil before mostly has a positive value now. But the one thing that's still missing is the install. So even though we've done all this work to tell Chef that we have all of these templates we want to create, we want to install this package with this version and this file, this checksum, we still haven't told it that we want it to install anything. And because we don't want it to apply to every machine in the company, we only want it to apply for people who've opted in some way. We can set that through some other recipe that's further along down the run list that is using some sort of gating to make that change to disk. So in our Chef run, we have a cookbook called CPGK, which stands for Gatekeepers. And one of the things that we can do is if somebody has joined an OS 10 or a Mac OS beta testing group, Chef does a call out to an API, says, hey, is this person a part of that group? They get a return of yes or no. If the user is a part of that group, then it flips that value from false to true. So then when it gets to the resource, Chef will actually install that package that you've defined. Additionally, there's kind of a opt-in function that we have where somebody can just run a command that lays down a value on disk And Chef will look at that file on disk and say, hey, has this person opted in to have this thing installed? And again, it's just a Boolean return, yes or no. If they have opted in, then it flips that value to true as well. So when the CP vfuse resource comes along to run, it gathers all this information and passes it along to the CP remote package resource, which then is responsible for downloading and installing the application. Similarly, we can use the file resource within Chef to create these individual templates. So we take all of that data that we defined earlier, including any dynamic data about, say you want to provide some of the stuff off corp. You might have a different URL for them to go to grab that. It'll check the checksum of the values on disk in the template. If that's changed, say 10.14.4 came out yesterday, and you want to change the stuff to have that new DMG be provided to them, you just make those changes in Chef, and it checks that file and says, okay, so this needs to be updated, and lays down the new file. One other thing we're doing here is we're collecting the path of all these templates into in line 3 there into an array. And the reason for that is because the Chef file resource is not totally idempotent. It won't go back and clean up any files that you're no longer managing. It'll only manage files that you want to manage. So if you have a template called High Sierra, and then Mojave comes out, and you want to give them a new template called Mojave and remove the High Sierra one, the Chef file resource is not very good about knowing what used to be on disk. So we collect that into a little array, and then we have a routine that runs that just compares the list of known templates that we want to lay down versus what's on disk, and then removes the ones that don't match that current list. So then when the user is opted in, Chef is run, everything is installed, they haven't had to do anything on their own, they don't even need to know how this thing works, they can just look up the templates that they have available to them and run the Mojave one. It'll download the DMG, it'll convert it for them, it'll plop it in their current user directory, and they can load a VM and do their testing without having to have installed anything at all. And then they can run against that template, and you'll see here it's downloading the DMG, it's creating a checksum, it's checking that against what it thinks it should be, it's populating the VMX file, and it's loading the VM for them right there. So I had a demo that I was potentially going to look at and show, but since I'm using their machine here, I'm not going to be doing that. But this is a gist that just has a quick runbook of an example of a few changes that you can make to a VM to kind of try out Chef. And also on our IT CPE repo on GitHub, we do have an intro README, which is kind of similar to this demo that kind of walks you through, cloning that repo locally and running some commands to run Chef 0 on your own system to make some example changes. And that takes us to Q&A. Thank you. Can't believe you're still awake.
Any questions, folks? Or
Hi, thank you. When you're sharding, the shard number is determined by the MD5 hash of the serial number. So the first % are always the same group of computers?
Yeah.
They must really like you.
They don't know. They get stuff early. Yeah.
Unless you enter an assault.
Oh, sure. Yeah. Actually, I have you. I put that on the screen, but I didn't read it. That's all. That's probably all from Frogger. Nobody knows what he's doing.
So every once in a while, we'll get a Mac that has no serial number or logic board's been replaced.
Yeah.
Serial number's not right.
Yeah.
Do you just throw the machine away? And
No, I think it defaults to like 0 or something, or no, it probably defaults to 99. If it doesn't, it should.
Okay, and then how do you handle like a couple of computers that are 99 then?
Sorry.
You said if it just defaults to 99, then you might have two computers with that same.
Oh, well, they'll just be in the 99 percentile of the sharding. So the idea there is they wouldn't get hit until the very end. Yeah. But that could cause other problems. If it doesn't have a serial number in the way that we have it set up, because we use the serial as the node name, as the identifier for the machine, then Chef probably won't even run. Or it may default to some other value, and who knows what would happen. That'd be kind of fun to see. All right. Oh, so close.
I'm sorry.
Teasing me.
No, I just wanted to thank you as well for your talk, and I really like the idea of having Chef talk to OS query, and I just wanted to ask if you could elaborate or maybe mention some other sort of tools externally to Chef which you find useful to communicate with during the Chef runs.
Yeah, I mean, the OS query thing is cool. It's essentially just shelling out to OS query I, and then bringing that data back in. So anything that you could shell out to, certainly you could pull in. You could have System Profiler grab a bunch of information and bring it back in. An example of an external, I'm having a hard time thinking of something. But you could do one of the things we do with our Monkey setup is we do local manifests that are configured locally on the system. So if somebody, with Monkey, people can opt in an optional install. It gets added to that manifest. We have an extra manifest on the system that's built by Chef. So if you go into your user customization, you can say, I want Fusion installed and iTerm installed and all this stuff. It'll add that stuff to your managed installs via local manifest. And one of the things that we do, I believe, is it actually looks out into the catalogs to make sure that app exists in the catalog before adding it as a managed install. Otherwise, we'll start getting a bunch of errors in Monkey. So we do interact with Monkey in a particular way there.
Thank you very much.
Any others or?
I'm kidding.
You use salt. What do you care? All right. Thanks a lot, guys.